My name is Enoc Martínez and I work for the Politècnica University of Catalunya. We have an underwater cabled observatory, so it's a fixed platform deployed near the coast of Vilanova, Geltrú, which is about 50 kilometers south of Barcelona. And we have all kinds, in fact it's a multiparametric observatory, so we collect all kinds of data from physics related like currents, waves, temperature, but we also have underwater cameras and we have been taking pictures since 2009. So we have like a 16-year archive of images and we are performing some biological studies also with this information. Our project, the main point is that we are using artificial intelligence to automatically detect fish species, but basically any kind of macrofauna in the underwater images. So the point is to automatically connect the data that we are acquiring through this artificial intelligence algorithm and then flow it in real time to embedded biology. So we will know instantly what's going on underwater, and we will have like an idea of the fish population at every given time in embedded biology. Our project more like a prototype because we have, even if we have like a pretty big archive of underwater pictures, it's basically a single point, so it may not be very representative in terms of area or spatial coverage. But the thing is that I think it's a good prototype to test these new technologies that are emerging and are booming lately. So it's a good opportunity to test the automated flow of automated identification of fish species into European initiatives like EMONNet and beyond, of course. The main goal of this project is to be sure that we connect our data properly with the European initiatives relevant in the biological field. So being involved in DTO-BioFlow will help us to try to connect these emerging technologies like artificial intelligence with European initiatives and to be sure that we can automate the whole pipeline from the image acquisition to the analysis until it's published into relevant European data portals. So the main objective and the main benefit of us being involved here is to be sure that our data is properly formatted and that it's really usable for the scientific community. Digital twins of the oceans are actually quite ambitious project or quite ambitious initiative. Let's see in the next 10 years, see if it really comes to a reality or not. But in any case, for sure it will help us to develop and to standardize a lot of data flows required for, let's say, big science analytics. That is for sure the trend in science. So we will need a lot of effort and to be sure that all the data is flowing properly through the proper channels and standards. So there can be models and statistical methods that can really take advantage of the massive amount of data that we are currently acquiring and which are not properly standardized at the moment. I mean, the ultimate goal of the digital twin, if it really comes to a reality, which as we know it's far away from now, but it will be to run what-if simulations. I mean, what-if simulations in the sense that what would happen if there's an oil spill in our region where we have these sensors and we have modeled the fish behavior, what would happen? Or what would happen if the temperature rises 5 degrees? Is it going to affect the fish population, or what if all the fish for this species left? I mean, it's the possibility to concatenate different models what makes it really interesting. But this is really challenging and, well, we'll see in the future if we can achieve this.